the fourth and final part of complex numbers of MFP1 of AS Level Maths. The final part isn't really any different to what I've previously shown you, but it's just a little bit more algebra involved, I would say. So firstly, I'm going to show you an example which you can follow. So I'm going to show you this example: 3 plus 4i p plus 2i equals q, add 26i. Okay, well, if you were first looking at this question, you would think, first thing to do, multiply out the brackets. Okay, so you do 3 times p, which is 3p. Then you do 3 times by 2i, which is add 6i. Then you do 4i times by p, which is add 4pi. Well, it doesn't really matter which way around they go. I just like to put the I last, just to emphasise that the number is an imaginary number. So then you do 4i multiplied by 2i, which is add 8i squared, and that is equal to q, add 26i. Okay, so then what I would do is I would gather all your real parts together and all your imaginary parts together. So as you know, I squared is -1, so -1 times 8, that would become a real number, so -8. So get all your real and imaginary parts together, so you've got 3p minus 8, okay, add 6i, add 4pi equals q, add 26i, and as you know, you can't gather them together because that's got a p term in it, and you just can't merge them together algebraically. So now what you do is you're going to equate the real parts and the imaginary parts, so you're going to compare them on either side. So I'm saying 3p minus 8 equals q, and then we have 6 add 4p equals 26. Okay, so I've compared the real parts of the equation and the imaginary parts of the equation. Okay, notice I haven't included the i's because we already know that these stems are imaginary. So, as a normal algebraic solution, you would take away the 6, so you have 4p equals 20. Then you're going to divide the 20 by the 4, so you know that p is 5. Okay, and because p is in your real parts, you can say that 3 multiplied by 5 minus 8 is equal to q. 15 minus 8 equals q. So q is equal to 7, and you've solved it. You've solved what p and q are from that horrible little equation that you saw at the start of the question. Wasn't too hard, was it?